Hello, hello, hello. Okay, guys, today what we're going to be doing is we're going to be taking and combining a few things. So we're going to combine these two lessons together, okay? And so this one really, if you have your hundreds chart done, this is going to go really easy. If you don't, I've been telling you for about a month to get it ready. So, and you've had that worksheet to have done, and about 3/4 of you have it. So I hope you got it done. But you're going to use the prime factorizations. You could use another method. I just want you to see how fast this is going to go. I want you to practice how fast it's going to go, so you could see the value of that hundreds chart. But after that, it's just your work. And then we're going to use it when we're talking about multiplying and dividing fractions. So we're going to put these two lessons together. So you will be taking some notes on page 9, 10, 11, and 12. Okay? All right, let's move on. Get ready. So you should be opening up your note packet to these pages. Go to page 9. All right, then. Now what you should see is you should already have these on your hundreds chart or on that worksheet that I gave you. So you just got to copy the prime factorizations of those 5 numbers, because that's what we're going to use to do these numbers over here on the right. Now notice these numbers over here on the right. Some of those might be missing on yours. Go ahead and fill those in too. Okay, so you're going to hit pause. You're going to fill those in. I'm just going to hit stop so you have time to do it. Okay, so there you are. Those are your prime factorizations. That should just come right. If you have your hundreds chart and it's done accurately, you should just copy that over. If you don't have your hundreds chart done, I guess you could copy these over there. Okay, so now what you're going to do is just over here where these numbers are listed, you're going to just put that same thing over to the right of them. Because what we want to do is find the greatest common factor and the least common multiple of these numbers. Okay, so we're going to start with the greatest common factor. So go ahead and just list out those prime factorizations over there to the right of those numbers. Okay, so you have those written out, right? Remember, greatest common factor. That means if we look at 20, 20's possible factors are 1 and 20, 2 and 10, and 4 and 5. That's it. And 36's factors would be 1 and 36, 2 and 18, 3 and 12, and 4 and 9. Now, when we look at greatest common factor, what we're looking at is what do they have in common? So if I look, they have 1 in common, they have a 2 in common, they have the 4s in common. Let's see, they don't have a 5 in common, they don't have a 10 or 20, so the 4 seems to be the greatest common factor, right? So that's the way you were taught to do it. And so if you didn't do it with prime factorizations and you did it this way, sometimes you make a mistake, you forget one, but it's very simple when you do it the way I'm trying to teach you, because here, when I look at the prime factorization, they have 2 and 2 in common. They both have 2 factors of 2, and 2 times 2 happens to be 4. So the greatest common factor is 4. So if you have your hundreds chart, you didn't have to go through this whole listing of all these numbers. You didn't have to worry about, did you miss one? You didn't have to look at your hundreds chart or your multiplication table and look for all the possible outcomes. You just had to look at your hundreds chart, say 20 is 2 times 2 times 5, that 36 is 2 times 2 times 3 times 3. Circle what they have in common, and there you go. You got 4 is the greatest common factor. Now, that's also what we use for simplifying fractions. So if I had 2036, I would just list that out as 2 times 2 times 5 over 2 times 2 times 3 times 3. And I would look at it and say, well, let's see, they have in common the 2's, and the 2's, what's left over is 5/9. Because there's only a 5 left on the top, and there's only 3 times 3 left on the bottom. So that means 2036 equals 5/9. And that's its most simplified form. So again, if I look at 35 and 20, I'm going to say, what do they both have in common? When I look, I could see that they don't both have a 2, they don't both have a 7, but they do both have a 5, but they only have one 5. So the greatest common factor is 5. That's the greatest common factor between 35 and 20. And then again in 12, we look at that, 12 and 36. We're going to, again, circle what do they have in common, right? We're going to look and see they both have a 2 in common. They have another 2 in common. They have a 3 in common. Matter of fact, they have 2 times 2 times 3 in common. This is the hard part, because a lot of people want to multiply this 2 times that 2 times this times that 2 times this 3 times that 3, but that's not what we're doing, because that would give us basically 144. That's not a factor of those two. That would probably be a multiple maybe of both of them, but actually that wouldn't even be a multiple of both of them. So when we're looking at the factors, we're only looking, as we listed factors over here, we're just talking about 2 times 2 times 3, which is, oh, by the way, that's 12 already. So I want you to see, and I'd like you to understand, there's 3 relationships that we could see in here. This relationship right here, they have something in common. It's like you and your friend walking down the street. You got something in common. You both might like the same music, wear the same clothes. Maybe that's the things you have in common, right? But not everything in common. These guys, they have something in common. They have the 5 in common, right? And this 12 and 36, they have everything in common. It's like being a twin or being a sibling, right? You have everything in common, and one's got maybe a little bit more, right? So, but we are only multiplying what they have in common to come up with the greatest common factor. Remember, factors are smaller than the number itself. Multiples are bigger than the number itself. So that's what you got to think about when you're trying to remember the difference between those. Now we'll cover this last one pretty quickly. If we got 26 and 35, 26 is 2 times 13, and 35 is 5 times 7. And I don't see anything there. So they have what we call the brother that nobody talks about, the 1. Right? They still have the 1 in common. So for these guys, the greatest common factor is 1. In other words, they didn't have anything in common. They're like someone you don't even know. You see them walking down the hall, you don't think you have anything in common with them. But you do have one thing in common. So you have that 1. You're both human beings, so at least we think so. Okay. So now we're going to do really quickly, go into this one. I just want to talk to you quickly. Go ahead and write out the prime factorizations for let's just pick the first 2 pairs, right? And we're going to just write out those prime factorizations. So you write it, and I'll put pause here. Okay, so those are filled out. And now what you want to do is we're going to find the least common multiple. So multiples of, let's say just multiples of 20 would be, you go down that multiplication table, right? On the 20 column, you're going to have 20, 40, 60, 80, 100, and 120. If we look at 12, you're going to have 12. You have 24. When you go down that 12 column, you have 36. You're going to have 48. You're going to have 60. You're going to have 72. You're going to have, what, 80, 84. Okay? And what do we have in common? What are the common multiples? because that's what that M means, is multiples. So what's the common multiples? And if I look, the only common multiples I can see so far is 60. Now it's going to wind up being 120 on the end, but we are looking for the least common multiple, right? And so we're going to look for the lowest, and that lowest is 60. Now remember what we did when we talked about the greatest common factor? Yeah, the greatest common factor of these two is 4, right? And if you look, once we find the greatest common factor, which was 2 times 2, which was 4, and we just multiply times what's left over, which is the 5 and the 3. 4 times 5 is 20. 20 times 3 is 60. Oh, look, that's the least common multiple. So again, if we look at 18, I'm not going to go through the listing of all of them, but if we look 18 and 30, that's the prime factorization. They both have 2 times 3 in common. 2 times 3 is 6, right? Times what's left over. What's left over? The 3 and the 5. So that's going to be times 3 times 5. And I know that 6 times 5 is 30. Times 3 then is going to be 90. That's the least common multiple between 18 and 30. Now look, you could go ahead and do the rest of these. We're probably going to do something with it in class, but do the rest of those in class. And if you want to practice, try finding the least common multiple out of these guys. Okay, so we're going to move on to the next step, talk about how we're going to apply this, how we're going to multiply and divide fractions, rational numbers. Here we go. Okay, now here's what you got to know. One thing, you're going to just apply these rules over here. Remember those rules? We're going to apply those rules over to these rational numbers. That's it. That's all we're going to do. Things you've already done in the past. I've shown you some things on how to do with your hundreds chart. So these two over here are pretty common. They're just basically you've done this in 4th and 5th grade, right? But now we just have to apply the rules. A negative times a positive, this is a positive, right? Negative times a positive is a negative. It's going to be a negative number. Okay, so now we know that's going to be a negative number. And so now we just have to figure out what 3/7 times 4/15 is going to be. Now, if I look at this, I know that 3, I'm going to have 3 times 2 times 2, because that's the 4, right? I'm going to have 7 times 3 times 5 is 15, which means I'm going to be able to simplify these 3's. Now, here's that part. Remember Bernoulli's prophecy. Okay, you got to not drop that negative. That negative's still there. It's a negative answer. What's left on top is 2 times 2, which is 4. What's left on bottom is 7 times 5, which is 35. So this is negative 4/35. That's what that equals. Okay, now let's look at this next one. Now, a negative times a negative is a positive, right? And if you forgot, go over there and write that crap on everything, right? Write that crap on everything. So you're going to put that on everything. You're going to look at this, say negative times a negative is a positive. Well, now this math just became similar to that math, right? We're just doing the same thing. Now we want to rewrite this as a usable fraction. So we write that as 6/1. We're going to write this as times 2/3. So that means we're going to have 6 is 2 times 3. And then we're going to have times the 2, right? And then we had the 1 on the bottom for this one, times the 3. And now we're just looking to see what simplifies. And what we can see is what simplifies here is the 3's. So 2 times 2 is 4. And over 1, this equals 4. And we know that, and we double check, go back and look and say, well, a negative times a negative is a positive. So this is a positive 4. There you go. That's how you do that. Now, look, you could go ahead and do this one because all you have to remember is that this is basically 3 when 1/5, right? So that means we have 3 holes, which it takes 5 to make a hole. So if we have 3 holes, that's going to be 15/5 plus 1/5, right? So that means we have 16 fifths here times negative 2/3. A negative times a positive is a negative. So the whole thing's going to be negative. Then we're going to have up here a 2 and a 3. And so what I wind up with is 16 is 2 times 2 times 2 times 2. And then 2 is just 2. And then 5 times 3 is supposed to be negative, right? And that doesn't simplify. 16 times 2 is 32. This is going to be negative 32 fifteenths, which is the same as negative 2 and 2 fifteenths. Now, this should be an acceptable answer, but that's the usable fraction. That's the mixed number. Okay? All right, now let's go on to the next step where it's a little. Now, you could go ahead and do these two problems over here if you want, these three even. But we really kind of did them over here, but they're just putting in the negative and the positive. Okay, so the last thing we're going to talk about is division. Now, remember, we have the same rules when we're talking about division, right? It's going to be that a positive divided by a positive is a positive divided by a negative is a negative divided by a positive is a negative divided by a negative is a positive. And all we're doing is determining what do we have for signs, right? So I'm going to do one of each one of these because this is pretty much review, except for remembering that if we look at these, we're going to say a negative time divided by a positive is a negative. So this number is going to come out to be negative. And a negative divided by a negative is a positive. So this number is going to come out to be positive. And this one here, a negative divided by times a positive is a negative, so it's going to be negative. Whatever we come up with, it's going to be negative. A positive times a negative is a negative. This number is going to come out to be negative. That's what we got to remember. That's all we really got to remember. So now what we're going to do is do a couple of these. I'll let you do some of them at home, and we'll do some of them. You can do some on your own, see what you come up with, okay? Because we're at 17 minutes. I don't want this to last any longer. We've tried to shove two things together at once. So, yeah, this is a little bit more work. Okay, so what we're going to do is first we're going to write these as usable fractions. So if you've learned the rule that, it takes 7/7 to make 1 plus 4/7, that's going to be 11/7 divided by, it's 2 wholes, so there's 5/5 in each whole. That means we're going to have 10/5, right? 10/5 plus the 1/5, that's going to give you 11/5. Okay? We already said this was going to be positive because a negative divided by a negative is a positive. Now what we have to do is invert and multiply, so you learn that keep part, right? And then we're going to invert, you called it keep change, right? And then we're going to invert it, and we're going to write the reciprocal, which is 5/11. We already said it was positive, so we're good with that. Now if we look at this, really these are all prime numbers, but because you're already in the habit of looking for that, you know that 11 and 11 simplify to be 1. So that means we just have 5/7 is our answer, okay? So you go ahead and do this one on your own. We'll talk about it in class, okay? Now this one here, we got 5/7. We said it was going to be negative. What we got to remember is we're to have 5/7, right? And this is 14/100. So we're going to multiply that times 14/100. We're not even worried right now about that negative because we've already determined it is negative, right? So 5 and 7 are both prime. 14 is 2 times 7. And 100 is 2 times 2 times 5 times 5. And what we're looking for, if we look, what we're really saying is these are all on next to each other. We're multiplying them. What do they have in common? We can see that there's a 5 on top and bottom. We can see there's a 2 on the top and bottom. We can see there's a 7 on the top and bottom. Wow, we got rid of everything on top. If there's nothing left on top, there's still the brother that nobody talks about, the 1. So this becomes 1/10. And we can't forget, we said that was negative. So this would be negative 1/10. All right. Well, we've been doing this for 20 minutes. I think that's long enough for anybody to do a video. So here we go. Now what you got to remember is you got to remember your rules, right? You got to keep those rules for multiplying and dividing integers. And you're going to use those now with rational numbers. You got to remember how to turn a number into a decimal or turn a decimal into a fraction. So that makes that easier, okay? And then you just got to remember how to simplify ratios. So when you write out the prime factorizations of each of the numbers, you just look for the ones. That's the gist of this. First, figuring out how to do the greatest common factor, least common multiple, and then second, how to multiply and divide fractions and use that greatest common factor. Okay, good luck. See you in class.